called math?
Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solve perimeter is?
2 times length plus 2 times width.
Good afternoon and welcome to your Tully Award-winning math homework hotline. Happy New Year!
Happy New Year!
We're in the new year with math homework help. I'm Mrs. Davis.
And I am Mr. Johnson.
We're here to help you with any math homework questions that you might be having. You can give us a call. The number will appear shortly on the screen. The number is 301-772-0080. We're here to help you with any math homework. So if you are working on your math homework, that winter break packet that you didn't quite finish up, or any math homework question that you might be having, you can give us a call here, and we are here to help you.
Now, how else could they get us besides the phone, Myrtle?
They can also contact us via the web at the Prince George's County page, www.pgcps.org, and click on your web broadcast. And you can email us at our email corner.
COU@pgcps.org.
All right, so we are here to help you with your math homework. And once you've called with a math homework question, you might want to challenge yourself. We have some 24 challenges, so please take a few minutes to jot these down so that you can have an answer ready for the 24 challenge.
And can you explain this to me?
24 challenge. Since it says 24 challenge, the challenge is to get a total of 24.
24.
You can add, subtract, multiply, or divide, or any combination of those 4 operations, but you must come up with a total of 24. So these are the numbers that you're going to use. However many times the number appears on the card, that's how many times you use it. So I will give you a chance to jot down card A. Mr. Johnson will tell you about cards B and D, and I will tell you about card C. So on card A, please jot these down. The numbers are 6, 2, 7, and 1. Card B.
And card B, you have 5, 6, 8, and 2.
Card C, you have 2, 8, 7, 2. Now, since you have 2 on the card 2 times, you have to use the 2 both times, as many times as it appears on the card.
All right, in card D, you have 2, 5, and 2 3s. Make sure you use them both.
All right, so that is the 24 challenge. We'll give you a couple of minutes to jot those down. And in the event that you want to challenge yourself in a different way, we have a different challenge for you. And this is find the digits.
Find the digits. All
so
right.
wherever there is a blank, you're going to fill in the numbers so that you are using all of the digits. So what number should you put here, here, and here? So I'll give you a few minutes to jot these down. And if you're just tuning in, the number again is 301-772-0080. All right, so we have our find the digit and our 24 challenge, and we are waiting for our callers. I hope you're tuning in for your math homework help.
So how you been, Miss Davis? I haven't seen you in a while.
I've been just wonderful. Did you have a delightful New Year?
Delightful New Year, delightful. I used all the math I could up in the ski lodges on the mountains.
With
I
the
tell
snow
you.
everywhere. You know, I didn't get a chance to go skiing, but I did have some snow around over the holiday. No, we actually got that snow after the holiday.
Yeah.
So, yes.
Okay, so look, let's look at some problems while we wait on our first caller.
Okay, well, what did you have in mind?
Problem of the day. Place these stadiums in order from least to greatest according to their seating capacity.
Oh, Wow. So we have a problem of the day. So if we're using our mathematical practices, what is the very first one do you think we should use in trying to figure out this problem?
Make sense of the problem.
Make sense of the problem.
Yeah,
Okay.
Yeah, that sounds about the right one.
Okay, well, let's see what we can do to make sense of this problem. Okay, so sometimes I have to read the problem more than once in order to make sense of it. So let me try reading it. Place these stadiums in order from least to greatest according to their seating capacity. And then it has a chart here for us to use. So we always want to make sure we make use of any visuals that are given to us, or if none are given, we can actually make a visual for ourselves, a diagram, a picture, a sketch to help us with the problem.
Okay.
So we have a chart. And what we want to focus in on is we're putting them from least to greatest.
And that's important.
That is important.
That is important.
So least, what does that mean?
The smallest number available.
Oh, the smallest. So we can think of this as small to large or big.
Okay.
So we can think of either one of those. Okay, so we're going to make these from small to big. How can you tell which number is small? It's a whole bunch of numbers for each one of these.
I know. So one way will be probably to start at the beginning of each number. Go
The
to the
beginning?
lead digit.
The beginning, like over here?
To the lead digit. Go all the way to the lead
How do
digit.
I know which one's leading?
The one that's at the very
Oh, over here.
front end of the problem.
Oh, the front end. Okay.
Front end.
All right, well, let's see. This is helping me out just a little bit.
Just a little bit. So when you look there, is there anything different?
Anything different? Well, let me see. I got on my special seeing glasses
Uh-oh.
here.
Uh-oh.
Let me see if I can see. Oh, wait, right here.
Right there. All right.
Okay, so all of these others have a leading digit with the 6. Now, what place value is that?
Okay, so let's start off at the very end of the number and work our way over. So that first one will be the ones.
Oh, okay, ones, then what?
Tens.
Tens,
And
okay.
then the hundreds.
Hundreds, and then the comma's here.
And that comma lets us know that we're getting ready to go into another family.
Oh, okay, well, which family is it?
Now we're getting ready to move into the thousands family.
Okay.
We just left the hundreds family. So now we have 1,000
1,000.
and 10,000.
Oh, this is 10,000.
All right, so we already know that we're going to start. We're in the 10,000 section. We can already see a difference going on. And you said that one number that was different. What was that?
This was a 5.
So right there.
So, but it's 5 10,000.
5 10,000s are in that number.
Oh, so then that's like 50,000.
And that will be 50,000.
Oh, okay. So then let's see. We're trying to find the smallest. So 50,000 and all these others are 60,000.
Mm-hmm.
So this would be my number 1?
That will be your smallest number.
Okay, and since we're putting them in order from least to greatest, is it okay if I put a number 1
Will
for
you
being
remember
the
what that means?
smallest?
Will you remember what number 1 means?
Yeah.
Okay. Well,
Because I'm going to go from, 1 is small. The next would be 2, and that would be bigger than 1.
Okay, so let's move and see if we can locate number 2. Now,
Okay.
what should we go to next? Now, I said start off in the lead digit. They helped me out that way.
Okay, the lead digit. Okay, let's see.
So then we went there already. So now after the lead digit, we should do what?
Oh, well, maybe. Well, we don't have any more going this way, so maybe we need to go this way.
All right.
Okay, so now let me see what we got. I'm going to use a different color.
All right.
Let's get colorful over here. Okay, so now I have 6, 5, 6, 6, 5, 5. Oh, my goodness. It's a whole bunch of 6s and 5s.
Okay, a whole bunch of 6s and 5s. So now we're looking for the least to greatest. So what's the least number there?
Well, I have a 5, and I have a 5, and I have a 5.
Okay, and then we have the other ones are 6s. So
Yeah, 6. So
we can leave those alone right now because we
those
know
alone?
6 is greater than 5, right?
Okay, so we're going to just work with these right here. The ones with
Okay.
the 5.
Just the ones
Well,
with
what place value was that again?
We said that was
which
the
place?
thousands.
Oh, okay. So now we looked at the 10,000s place value. Now we have to look at the thousands place value.
All right, and now we see that we have 3.
Okay, wait a minute. So we got 3. Oh, yeah. I
We
have
have
3
three
dots.
numbers with 5 in the same place value.
And that is 5 in the thousands place.
That's right.
Okay, now what?
So we know that they're even right there.
Okay.
So far, those three numbers are even, right? So then we should follow your little arrow again and move over to the next place value, which is going to be the...
Okay, we're at thousands. Next is the comma place value.
That's right. So we're leaving that thousands family, and we're moving back over to the hundreds family.
Oh, the
All right.
hundreds. Okay. I'm going to alternate. This is going to be red. Okay, so let me underline. Oh, so do I underline all of them or just the ones I
Just
put
the three with the dots, because we already know that the 6 was greater than the 5 in those thousands.
Oh, okay, so just the ones with the blue dots. Okay, so I got 600.
Okay.
300.
No. We skipping over that one.
Oh, I'm skipping over that
skipping
one.
that one. No dot
Oh, no dot.
there. No dot. There you go.
I made a little mistakey poo. All right, so here's a 6.
And then we have a
3.
All
Okay, so
right.
let me see, what do we have? We have 600. We have 600. We have 300.
And right there, you can tell just by announcing those numbers.
Oh, okay, so can I put a 2 here?
I will put a 2 there.
All righty.
All righty.
Okay, so we're done with these two. So now I have to go back to these two?
All right, and then switch back over to another color, because we're going to
Okay.
leave the hundreds and we're going to move to the right again to our tens.
Oh, tens. Okay, let me put tens right here.
Okay.
Tens. Okay, so I'm just working with the ones with the
two.
dots. Okay, what do we got? Oh, 0. I already know 0 is small.
Okay.
0.
And then we have a
7.
7. So you already said you knew something.
0.
0. So
0.
0. So that would have to be.
0 is our hero. It is the smallest.
0 is the hero. Okay.
Okay, so I got 3.
And that's
so now
3.
this was 7, right?
That's right. And that's the last one with a dot. So that one will be number 4.
Okay, so I have the smallest. So they're small, big, bigger, bigger.
Bigger than bigger.
Oh, okay. Small, big.
1, 2,
No,
3,
small.
4.
Big.
We got to ring the
bigger.
bell for you. I'm not sure. Happy holidays. All right. I'm not mad at you. All right. Happy
All
New
right.
Year's. Okay, now let's move back up. We got 2
Okay,
left without
so
dots.
wait a minute. We've used 1, 2, 3, 4. Okay,
right.
so we have 2 left.
We have 2 left. Okay.
All right, so
we went
let
back
me
and we
see. Let
realized.
me see. You said keep moving over towards my arrow.
Right.
Okay, so then I go back to
Our last spot.
the last spot that I underlined. So I got to go
Mm-hmm.
to the 10,000s place.
No, that wasn't the last one. See that little blue underneath?
Oh, the blue. Okay, so now I got to go to the thousands
Go
place.
back to the thousands for those numbers.
Okay, so let's see. What do we have? I'm gonna put a red dot next to these so I can figure out what is going on. What in the world is going on? Okay, just those two.
That's those 2.
Okay, so let's
We
see.
stopped at blue with
We
the
stopped at
1,000.
blue, so we need red.
And we're moving to the right, which you said
Okay,
was
so
now the
okay,
100.
I underlined that 3 and this 9. Okay, so this would be 900 and this would be 300.
Okay.
Okay, so 9 is bigger than 3. Okay, so I left off at 4, so this would be 5. And would this be 6?
And that will be 6.
Yippee!
All right.
I've numbered it from 1, 2, 3, 4, 5, 6.
And 6. All right.
So then do I have to say them?
So now you just have to put them in order
Okay.
normally, so someone
Normally?
would know. Unless you're going to put a key with this when you turn it in. You're going to have a key to let them know what's going on with all these numbers here.
Oh, okay. 1 is the smallest or the least, and 6 is the greatest. You think that's okay?
What happened to all the numbers in the middle?
Well, okay, can I put dot, dot, dot? Okay, you're right. I need to be precise.
And you need to order them using the numbers, or you can put them in order by the stadium's letters.
Okay, well, let's see. Let's go back to the problem to make sure we're answering the problem.
Okay.
Place these stadiums in order from least to greatest.
So we need to put the stadiums
according
in
to
order.
their capacity. All right, so then
We have stadium. Which one is first? S.
Oh, wait a minute. What
You
stadium
gotta put
is
the
it?
one in
R.
R. There we go.
Okay, so do I have to put the word stadium?
You gotta put the letter.
Oh, okay. I'll just put the letter then.
Yeah.
Okay, so number 1 is Stadium R. And number 2 is Stadium V. Number 3 is Stadium B. Okay. Okay, now it's for Stadium T. 5, Stadium J.
TJ.
And Stadium 6 is Stadium S.
There we go.
Okay, we have now put them in order according to their seating capacity. Stadium R, Stadium V, Stadium B, Stadium T, Stadium J, and Stadium S.
All right.
All right.
That was a lot of work. That was a lot of work.
It was. And the secret to all of this was knowing your, what did you call these things?
Place value.
Oh, so in order to put something in order from least to greatest, we have to use place value. That is our key to putting things in order from least to greatest.
All right. Happy new year. This is a brand new year. Uh-oh, we on a roll here. Now if we get some phone calls, we're going to be off the chain. I'm telling you.
All right. And just in case you're just tuning in, the number is 301-772-0080. We're here to help you with any math homework that you might be having. And I think we might have some viewers who are tuning in from all across the county, including Bowie, Maryland. And I think maybe Miss Shepherd and Dr. C's class is tuning in. And I'm inviting you to call. And all of the students in all of the schools across Prince George's County, we're here to help you with your math homework, so give us a call. That number again, jot it down. Don't forget, 301-772-0080. We indeed want you to have a fabulous new year. So join us here with your math homework questions.
And what happens when they call in?
Oh, when you call in, we are going to give you a shout out.
A shout out.
Yes!
How about this pretty little box?
Oh, well, I'm going to shout out. I'm going to get so excited. You haven't seen me excited yet.
Uh-oh.
I'm going to get really excited because I really enjoy helping out the students with their math homework. Once you call, your name is going to go into our treasure chest because we treasure all of our callers who call across the county. And you can even watch us on the World Wide Web at www.pgcps.org. And tune in on the Student Homework Help broadcasts, and webcasts is where you'll find us. Okay, so we have found the stadiums in order from the least to the greatest. Oh, and again, in case you are just tuning in, you can challenge yourself. Let me show you those challenges one more time.
All right.
The challenge is...
There you go, right over there.
The 24 challenge.
All right.
Okay, now how do you do this again?
All right. Now you say on the 24 challenge, they must be able to either add, subtract, multiply, or divide. They can use any of the operations, but they have to use the 4 numbers, all 4 numbers that show up on that one card. Now, you said that this was a 6. How do I know that that's a 6 and not a 9? Why can't I call and use that as a 9?
Well, let me see. The card's supposed to go this way, so you turn it, and that's a 6. If it was a 9, it would be shaded in red.
So since it's not shaded in red, we know that those are 6s on the board, okay?
Okay, so let me repeat. Please take a few moments to jot this down. Card A, 6 because it's not shaded in. 2, 7, 1 is card A.
Card B is 5, 6, 8, and 2.
Card C, 2, 8, 7, 2. And since we have 2's on here twice, that means you have to use 2 times.
Card D is 2, 5, 3, 3. And remember, just like Miss Davis told you, use both the 3s. Now, what are these little colors?
Oh, the little colors.
The little dots on
So you know which one is which?
Oh.
Card. Oh, so, hey, well, is it kind of like least to greatest?
It's sort of like least. I believe it would be.
Okay,
like
so
if it
this
just
is
had
1, 2,
two,
3.
So this must be the easiest one. Not so it's saying compared to the other ones, this might be a little easier for the caller to answer.
Oh, okay, so this might be considered an easier card to solve. Maybe, I wonder if it has anything to do with the number of operations that you could use.
No, I think it's just...
Okay, it could be considered relatively easy. Relatively.
Okay.
Some might be easier, some might be harder.
Now, how about if they call in and they want to use the same card? Can they use it?
Well, they have to have a different solution.
Different solution, but for the same card.
Yeah, they could use the same one, just a different solution.
Okay, and we're going to keep note of that, right?
Yes, and I'm wondering if we have a caller.
Yeah.
So for this one, it is a 2-dot card, so that means
It's a little bit more
you
challenging.
might want to think about it a little bit carefully. But you can always use your facts.
Mm-hmm. And that's a good strategy to give them. Yeah, so that's a good strategy to have
Yes.
them going.
Okay, so we have card C. Oh, we did card C. It's a 2-dot. So maybe these two are equally challenging.
Mm-hmm.
And this 3-dot might be a little bit more challenge, but we are sure all of you can meet the challenge. Yes.
And if they get it right, they get it. Their name goes in the
Oh,
box.
and twice. So
It
you're
goes in?
twice as likely to win a fabulous prize.
Fabulous. And it's a new year. It's no
It's a
telling.
new year.
Mm-hmm. We got cars waiting outside. No, that's the wrong game show. Wrong show.
wrong
No cars.
No cars.
No
But here's
cars.
our other challenge where we're finding the digits.
Okay.
So we're trying to figure out which digit can you put in here to make this entire thing correct. And we are using addition. So what can we have here to make this a good solution? So maybe I'll just let you take a... Oh, we have another thing to do?
You want another problem of the day?
Oh, well,
All right.
you know,
Here
we're
we
just
go.
here.
Yeah.
All right, so we're going to use math practice number 1. Read and understand the problem.
Make sense of the problem.
Make sense of the problem and persevere with solving it. Oh, I have to make it. Okay, well, let me read over it. Jason has 87 cents in his pocket. He took out 3 quarters. Ooh-wee. List all the possible combinations of coins he could have left in his pocket. Ooh, well, I have to know how to count money.
Yeah. Got to know coins.
You have to know coins.
Have to know coins.
So on your debit card, you don't get coins.
What's a debit card?
You know the little thing. Cha-ching.
Oh.
So you
Miss
have
Davis
to know
got
how
a lot of money. She charging it. She charges it. I do the IOU system.
Okay. All right. We have been delighted to share our problem of the day, but now we have a caller. Caller, are you there? Welcome to Count on Us. Hello? Hello? Caller? Are you there?
Hello? Hey. I hear someone.
Hi, welcome to Count on Us. Happy New Year. Can you tell us your name and the school you're calling from? Your school you go to?
Huh?
Your name, please? Can you say your name for me?
Why?
Say it so everyone can hear it.
Huh?
Say your name.
Why?
What is your name?
I got you, Y. Hey, Y. That's your name, Y?
Hello?
Are you still there? Uh-oh.
You
scared him.
I did not.
I think you did.
Wawanda. Wawandi.
Uh-oh. You scared him.
Wawanda, I see. I
Call
wanted
right
you
back.
to say your name so I could say it correctly. I
And
wanted
call
to
right back.
hear. Wawandi? Was that Wawandi? Okay, Wawandi, we are waiting right here for you, and all of the callers across Prince George's County, we are waiting to hear from you as well.
All right.
As you are buckling in for a nice, chilly, cool evening, you can get your math homework done with help. So give us a call. The number again is 301-772-0080. We're here to help you with any math homework that you might be having. So all of the people tuning in, go ahead. Think about a math problem and give us a call. And while we're waiting patiently for you to call, we are going to take a look at Jason and his money problem.
Right.
Okay, so we have to make sense of this problem, Mr. Johnson.
So that has a lot of steps to it. It seems like it's going to be really short, but it's really not, because it said possible combinations.
Okay, well, maybe we need to read it again. You want to read it this time?
Jason had 87 cents in his pocket. He took out 3 quarters, so that's important. He took out 3 quarters.
I'm going to draw Jason. Look at Jason. Oh, I guess he needs a pocket, doesn't he?
List all the possible combination of coins he could have left in his pocket.
Okay, so Jason has some pockets.
Okay.
Okay, so let's see. What is it asking us to do? That's the main thing. List all the possible combinations of coins he could have left in his pocket.
Okay, so first we got to start off with the 87 cents.
Okay, well...
and he's going to take 3 quarters out from that.
Okay, so maybe we need to do it on a separate sheet, because we might have a lot going on here.
That's right.
All right, well, let's see. 87 cents.
87 cents.
So that's no dollars. And just 87 cents.
And we know he pulled out 3 quarters, so right there.
Okay, so 3 quarters.
Pull out 3 quarters.
So
3 quarters will be.
Okay, so if we're making, it says make an organized list. So, what kind of coins could he have?
He definitely could have some pennies.
Okay, so he had. Should we put quarters, or quarters are no longer in his pocket?
And quarters are no longer in his pocket.
Okay, but he has to have 87 cents. So this has to total up to 87 cents, right? Okay, so he had some quarters. Can I just put Q for quarters?
That'll work for me.
Okay, then what else could he have had?
Dimes.
Dimes. Can I put D for dimes? And then what?
Nickels.
Nickels. N for nickels.
And P for penny.
And P for pennies.
All right.
Okay. So
we know he had 3 quarters, so
okay.
put 3 in that Q spot.
Okay, put 3 in the Q spot. So this is going to stay 3 the whole time. Okay, well, how much is 3 quarters?
Let's see. 25.
Oh, wait a minute. 1 quarter.
25.
1 quarter is 25 cents.
25. Okay. So 2 quarters would be?
2 quarters
would be another 25.
Which would be another 25. So that would be 50 cents.
There we
Can
go.
I write it like that?
You can.
Okay. Now what?
3 quarters.
3 quarters.
And if we put 1 and 2 together, we know that 3 quarters is 75 cents.
Oh, 75 cents.
Okay.
75 cents. All right. But it said he had 87 cents.
That's right. So we're trying to figure out all the ways that he can have.
Well, how do I know how much money he had left once he took the quarters out of his pocket?
How about a little subtraction?
Oh, he took them out of his pocket.
So
okay, so this is 75 cents. Okay, I'm going to put it under here like this.
Okay. And 87 cents take away 75 cents.
87 cents take away 75 cents. Now what?
7 take away 5.
7 take away 5. So do I count forward or count backward?
Backwards or forwards is up to you. You can go from 5 and count forward.
Okay, so here we go. 5, 6, 7.
There you go.
Oh, now how can I count backwards?
7.
7.
6.
6, 5. Hey, it comes out the same either way.
There
so that's 2.
That's 2.
Okay, now what?
Now we move to our dimes.
Dimes?
8 dimes take away 7 dimes.
Well, give me just 1 dime.
So
So I have 1 dime and 2 pennies?
Mm-hmm.
Hey, I'm going to fill that one in.
Big money, big money.
Okay, so I can have 1 dime.
1 dime.
Which is 10 cents.
And
0 nickels.
there we go. And
2 pennies.
2 pennies.
So this is 0 cents and this is 2 cents. Okay, so now 75 plus 10 is 85. 85. Hey, we need a hundredths chart to keep track of all. Okay, so I think we have 87 cents.
Okay.
You know what? We're going to ask you to join us on the other side of the break to help us figure out how many additional combinations can he find for the remaining coins in Jason's pocket. We're going to need your help. So stay tuned and join us on the other side of the break. We'll be right back.
Be right back.
hours, I have to multiply 720 times 60 because 60 minutes equal 1 hour. And that equals 43,200 minutes. Next, in order to find out how many seconds are in 43,200 minutes, I must multiply 43,200 times 60, because 60 seconds equal 1 minute. And that equals 2,592,000 seconds. So 30 days equal 2,592,000 seconds. Woo! That was a lot of seconds. I hope you found the solution to your problem easy to follow. This is Jessica from Counting Us. Bye. See you next time.
Hey you, yeah you, stay right there, I gotta tell you something. I bet you know someone with type 2 diabetes. Guaranteed, you know why? Because 1 out of every 3 little kids is gonna develop diabetes in their lifetime. That is gonna lead to heart problems, strokes, and even blindness. I'm John Sally, and I'm telling you, it ain't gotta be that way. Now you can up your defenses by eating more fruits and vegetables, having more vegetarian and vegan meals. These steps can be the power plays to protect you and your family against the risk of diabetes. To learn more, go to blockdiabetes.org. Okay.
He was so inspiring.
He took chances.
He was so moving.
He lived daringly.
Martin Luther King Jr. was a man of service, and his day shall be a day of service.
He inspired us in words, but he led us in deeds. To honor him, let's do the same. Go to mlkday.gov and find out how to volunteer on Martin Luther King Day and beyond. This message is brought to you by the Corporation for National and Community.
Okay, guys, ready? Here we go. Let's smile and brush our teeth twice a day, every day. Let's smile and floss our teeth once a day, every day. Let's keep that smile a happy place on your face with good nutrition and dental visits. Let's smile. Let's smile. Let's smile. Let's smile.
Happy New Year. Welcome back. Hello, everybody. Hey, Miss Davis. Woo, it's the new. I like that hat and those glasses.
Oh, it's
you are stunting. You are stunting. It's the new year.
A new year and a new look.
I got my new hat.
Oh, I love that purple.
We purple down.
We purple and black and red and all the
you
other
a whole
colors.
lot of colors.
All the other colors
You a
of
whole
the
lot of
rainbow.
colors. All right.
We are here to help you with any math homework that you might be having this afternoon.
Count on us.
Count on us. We'd like for you to give us a call. The number here is 301-772-0080. So the object is to get your math homework done. Don't struggle all alone. Give us a call on the telephone.
We're waiting.
We'll be right here to help you out with any homework you're having.
That's right.
No need to fear at all. And once you call, you can even challenge yourself with some additional problems. Okay. We have our 24 challenge. And do we have a caller? Caller, are you there? Hello? Caller,
Hello?
Are you there? How are you?
Yeah. Good.
Can you tell us your name, please?
Salafina.
Salafina. Oh, that's a beautiful name. Now, what school do you go to, Salafina?
Leonard and Woods.
Oh, well, yay! Ring your bell.
I think this is my buddy Salafina. She
ring
called
your
last
bell.
time. She
Ring
was
your
ring the bell.
bell.
Hey, Salafina. Hey, Glenard and Woods in the house. All right.
Glenard and Woods in the house. Now, Salafina, I don't think I've helped you with a question before.
So I'm going to let you help her.
No. So are you a first-time caller or a frequent fan of Count on Us?
This is my second time.
Yeah.
All right. Well,
Yeah.
welcome back. Did you have a nice holiday break?
Yeah.
And did you do any winter break packets over the homework, over the break?
Yeah.
All right. You get them all done?
Mhm.
Oh, very good. Now, what grade are you, Salafina?
I'm in fourth.
All
Fourth
right.
grade.
And are you multiplying fractions?
Yeah.
All right.
All right. Well, we are both delighted that you call.
Okay, so what's your problem, Salafina?
2/5
2/5
times 5/6.
times 5/5.
5/5 or 5/6?
5/6.
6. Okay, there you go.
Okay. All right. You're in fourth grade. So what have you learned about multiplying fractions?
Well, my teacher told me that you have to multiply the denominators and then multiply the numerators.
Okay. And did you guys have to sketch any visual models?
No.
No? All right. Well, let's see if we can see visually what it looks like first, and then we will attempt to solve it, okay? So what does 2/5 mean? If I have 2/5.
What does 2/5 mean?
What does...
It means that there's 5 in all, and that there's only 2 out of 5.
Okay, so we have a hole, so I made my hole a little bit bigger, so I'll have room here. Okay, I have a hole, but I only have 2/5 of the hole, so that means I'm breaking it up into parts, yes?
Yeah.
There you go. All right.
How many parts do I need to break my hole up into?
5.
All right.
So do I have 5 parts? Can we check? 1, 2, 3, 4, 5. So I have 1/5, 2/5, 3/5, 4/5, 5/5. So my whole is broken up into fifths. All right. Now, how many fifths are we considering right now? Do we need all 5 of the fifths?
How many do we need, Salafina?
2.
2.
Okay, so I'm going to put polka dots on these 2. Is that all right with you?
Yeah.
Okay. So here are my 2 polka dotted fifths.
Okay.
Now, my second fraction says that I am multiplying. I'm going to take 5/6 of my 2/5. Okay. So, going the opposite direction,
okay,
I'm going to divide my whole up into 6.
6 parts.
6 parts. So
2 more lines there.
My dots are in the way. Okay, we're going to regroup these dots in a minute, so never fear.
Okay.
Okay.
There you go.
Okay. All right, so let's see. With my red, can I count my red sections? How many red sections do I have? I'm going to put X's on the red sections.
Okay.
1, 2, 3, 4, 5, 6. Okay, so the red is now going this way. Can you see the red, Salafina?
Yeah.
Okay, so you see how the red is going the opposite way?
Yeah.
Okay, so I have 6 parts there in red. All right, and how many of those red pieces do I need?
5.
5.
There you go. All
Okay,
right.
so right here. So I'm going to fill in 5 red with X's. So that's 1, 2, 3, 4. Okay, is that 5? Let's check. 1, 2, 3, 4, 5. All right. Now, Salafina, we're looking for the parts that have both X's and polka dots. Okay?
Okay.
All right. So can we tell which parts have both X's and polka dots at the same time?
Yes.
Okay. How many have X's and polka dots? 1, 2, 3, 4, 5, 6, 7, 8, 9.
10.
How many? Salafina?
Yes.
How many have both X's and polka dots? Did you count with me?
10.
10.
There we go.
Now, how many little small squares do we have in all? 1, 2, 3, 4, 5. So this is 5, 10, 15, 20, 25.
And
30.
30. There we go.
Okay, so we have 30 small squares in all. So we have visually seen that 2/5 times 5/6 is equal to 10 30ths. And if we multiply numerator times numerator and denominator times denominator, do we come up with that?
Yes.
Okay. Now, do you need to simplify or no?
Yes, you need to simplify.
And what would you simplify this to be?
Well, you simplify it by 10.
Okay.
By 10.
By
okay.
10.
All right.
Are we?
So it would be 1/3.
1/3. All right.
Absolutely.
All right. Here we go. Glen Arden Woods is rocking today. All
Glen
right.
Arden Woods is being represented.
I got her name. I got her name.
All right. So your name is going in. So please stay tuned to the end of the show to see if you are the winner of a fabulous prize. And our callers have picked up, so we will pick up the pace as well. So, Salafina, please stay tuned to the end of the show to see if you are a winner. Okay, and we have another caller.
Next caller.
Are you there?
Yes.
Hi, welcome to Count on Us.
Hi.
And your name, please?
Ibrahim Bangura.
Okay. His name is?
Ibrahim.
Welcome. And now, is this your first time calling, or are you a frequent fan?
First time calling.
Woohoo! Oh, we're going to be ringing the bell all day now. Uh-oh, see, we done picked up now. We're on 5. All right.
For you.
Now,
all
what
right.
we got going on? Multiplying 3-digit by 2-digit. Is that what you're working on?
No.
Okay,
what are you
working on?
I'm actually doing a 3-digit.
3-digit?
Okay.
3-digit what?
That would be 669 times 9.
669 times 9.
Right.
Okay, and you are multiplying.
Yes.
What grade are you? What grade are you?
Hmm?
What grade are you?
Third.
Third grade.
All
Okay.
right.
Third
All
grade.
right.
All right.
Very good. And Mr. Johnson is going to be happy to help you with this, and I am just going to write.
You're just going to write?
Uh-huh.
Okay, Ibram.
Okay,
Yeah.
is he going to estimate?
Now, when you look at 669, what is that close to?
That was 66.
669, what is that close to?
660. That is close to 670.
670. So you round to the tens.
Okay.
Okay, now, can we get a little, what 100 is that close to? 669.
That is close to 700.
700. All right. That's what I'm talking about. 700.
So, 700. All right.
Okay. Now, 9. What is 9 close to?
It is close to 10.
10. Okay. Now, is that number a little easier for you to work with? 700 times 10?
Huh?
700 times 10, is that an easy number for you to work with?
Not really.
If you had 10 700s, you don't think you can add that for me?
Yes.
Yeah, I think so. What is 10 700s?
10 700s.
Think of 1 times 7.
1 times 7.
7. And how many zeros do you see in that number? 700 and in a 10, how many zeros are all together?
3.
3. So 700 times 10 would be what? You just told me a 7 with 3 zeros. What's a 7 and 3 zeros?
7,000.
There you go. So we know we want to get somewhere close to 7,000. Would you agree with that one?
Yes.
All right. So let's go back to your first problem. 669 times 9. So what should we start off with? Where should we start in that problem?
9 times 9.
Want to start with 9 times 9. You know your facts? What's 9 times 9? All right, let's get real quick. 9 times 10.
That's 90.
So take away 9 would be?
90.
What was that?
81.
81. There we go. So where do I put the 1?
Put the 1 where the 9 is.
And what would I do with the 8?
Put it at where the 8 is.
Put it back where the... Oh, with a 6 is? Oh, you're already watching it do it? Okay. Now, what do I do next? What's the next number that I move to?
You move to 6.
Okay, so 9 times 6. Okay, what's 9 times 5?
9 times 9 is...
No, 9 times 5. Do your 5s. You get close.
Oh, okay.
What's 9 times 5?
9 times 5 is 45.
45. And now if we added 9 to that, you would get what?
49.
45 plus 9.
45 plus 9. It would equal... 54.
There we go. 54. All right. So now we know that 9 times 6 is 54. So where do I put the 4? Oh, where? Uh-oh. We had a plus 8 on top.
So
54 plus 8?
that would equal...
And can I break that 8 up to help me? 54 plus 6 would give me what?
Would give you... That would equal 62.
That will equal 62. You're right, when we put it all together. Okay. So 62. So now I put the 2 where?
Under where the 6 is.
Okay, and then I move my 6 to
the on top of the 6.
on top of the other 6. And now this should be easy because 9 times 6 again?
That would equal 54.
54 plus 6 more.
Will equal 60.
60. Okay. And where do I put the 60?
You put it where the 21 is.
All right. And so now how do I read that number?
6,021.
6,021.
Very, very good.
Third grade. Oh.
All right. And was that, it was kind of close to our 7,000. We knew that our answer would be less than 7,000. And so 6,021 is less than 7. Very good job. We're going to put your name into the apple, so please stay tuned to the end of the show to see if you are the winner of a fabulous prize.
Now, were you calling from Glen Arden Woods?
Yes.
All right, that's two. Glen Arden Woods.
In the house.
All right.
But we do have another caller. So, caller, are you there?
Yes.
Hi, caller. Welcome to Count on Us. Could I have your name and which school you attend?
Christian and
Christian. Is this the Christian that goes to, what school is that?
Mattapanai Elementary.
Mattapanai.
How you doing, Christian?
You know
representing Mattapanai.
You know Christian.
Christian, are you a first-time caller or a frequent fan?
First time caller.
Woo-hoo, there we go again. That's 3. Oh, there we go. 3 rings. All right,
With
Christian.
Our first-time callers, we're so delighted you joined us today. Now, what can we help you with?
A word problem.
A word problem.
All
right. Now, remember, whenever you're doing a word problem, the first thing Mr. Johnson would always tell you to do is read and
make sense of the problem.
Read and make sure you understand the problem. Now, do you know what type of math is in that problem?
Fraction.
Ooh,
Fractions.
we love fractions.
Now, what grade are you, Christian?
Okay. Jackie has...
Christian, one more thing.
What grade are you?
Yes.
What grade?
Oh, 4th.
4th, okay.
Grade.
Fourth grade. All right.
So we're working with a fraction problem. All right. We're going to listen very carefully, and we're going to try to take down the important information to help you with the problem, okay? And what school? You said Mattapanai. All right. Go ahead, Christian. What is the problem?
Jackie has 1/6/12 pitchers of fruit juice. She and her friends drink 4/12 of a pitcher. How much fruit juice does Jackie have left?
Okay. All right. So I heard 1/6 and 4/12. So both of us, Mr. Johnson and I, both have to understand the problem. So Jackie has some fruit juice. Is that correct?
1/6 of fruit juice.
Okay. Jackie has. What does Jackie have?
1/6 of fruit juice.
1/6 what?
Yes.
1/6. Okay. Read the problem one more time.
Jackie has 1/6/12 pitchers of fruit juice. She and her friends drink 4/12 of a pitcher. How much fruit juice does Jackie have left?
Okay, so Jackie has 1/6 of a pitcher of fruit juice.
1/6/12.
1/6/12?
1 and 6/12.
Oh, 1 and 6/12. Okay.
All right.
All right.
That is what
okay.
was going on.
Okay.
All
1
righty
and
then.
6/12. All right.
All righty. All right. Okay. So she has 1 and 6/12 of a pitcher of juice. Okay, and they drank this much. Okay.
That's looking good so far, Christian.
Okay, is that correct? There was 1 and 6/12 of a pitcher of juice, and they drank 4/12 of the juice.
Yes.
Okay. So, did they drink up all the juice, Christian?
Jackie has 1/6/12 pitchers of fruit juice. She and her friends drink 4/12 of a pitcher. How much fruit juice does Jackie have left?
All right. So, she drank some of it.
Did they drink all of it, Christian?
No.
No, we know that one. Okay. We know.
All right. So, we are going to... Should we add together, subtract, multiply, or divide? What do you think we should do with this?
Subtract.
Subtract.
Okay.
All
Subtract.
right.
Okay. Now, so we're going to subtract the 12ths from the 12ths. So if I have 6/12 and I want to subtract 4/12, how many 12ths would I have left?
You will have 2 12s.
2 12s. All right.
12s.
2 12s. All right.
Okay, we have 2/12 of a pitcher of juice. So 6 subtract 4 is 2. No, and we were dealing with 12s. So do I still have this whole part of the picture that she hasn't drank any from? So 1 subtract 0 is?
1.
1. So they have how much of the fruit juice remaining?
1 and 2 12.
1 and 2 twelfths of the juice remaining.
Did you have to leave it there, or did you have to simplify that?
Simplify it.
Oh, how do you simplify 2 over 12?
2 twelfths. How shall we simplify 2 twelfths?
What do we use to simplify 2 twelfths, Christian?
2 goes into 2 one time.
2 go into 2 one time. Okay.
2 goes into 12 6 times.
6 times.
So
1 over 6.
okay, and we still have the whole pitcher of juice.
1 1 6.
1 and 1 6. All right, let me go ahead and write that name down. Matapanai is here.
Christian at Matapanai doing great things. Christian, thank you so much for your call, and stay tuned to the end of the show to see if you are the winner of a fabulous prize, okay?
All right.
Thank you, Mr. Johnson. Thank you, Miss Davis.
All right. Man, Christian, I'm saying. All right, Matapanai.
Representing. Okay, I think we have one more caller in just a few minutes to help them.
Okay.
All right, caller, are you there?
Yes.
Hi, welcome to Count on Us. Can you tell us your name and the school you attend?
The school I attend is Glenarden Woods.
Glenarden Woods. And your name is? What's your name?
Desiree.
Desiree, welcome. Now, Desiree, I have a question. We're so delighted that you called. Now, is this your first time calling, or have you called before? You're a frequent fan.
Huh?
Is this your first time calling?
Yes.
Okay, all right. You're going to get a number 1 now. We need to hurry up. So
okay, you're doing multiplication.
Tell us your problem.
Mr. Johnson and I will help you out. Go ahead.
Okay. The math problem is 845 times 9.
Uh-oh, these 9s.
Okay.
It's these 9s.
Okay, go ahead, Mr.
So we can go real fast. What's 9 times 5? We can do those 9s real easy with our 5s. Let's go to the 5s. 5, 10, 15, 20, 25, 30, 35, 40. And 9 times 5 is?
45.
45. So we put that 5 right up under the 9, carry that 4. Then we go 9 times 4. What's 9 times 4? 9 times 4. Come on, we said 9 times 5 was 45. So 9 times 4 will be 9 less than 45, which is?
36.
36.
Oh,
all right.
good.
We put that 6 there plus 4 more. Hold up. 36 plus 4.
36 plus 4.
36, 37, 38, 39.
Very
40.
good.
Put the 0, carry the 4. 9 times 8. We know that 9 times 9. You know your 9s. 9 times 9 is?
9 times 9 is 81.
So we take away 9. 9 times 8 is?
What's 9 times 8?
Uh-oh. What's that?
81.
70 what?
Oh, 72.
72. Okay, 72 plus 4 more. 72 plus 4 more.
Huh?
72 plus 4.
Oh, 72 plus 5.
4.
72 plus 4.
Yep.
Is 76.
76. Excellent job. So we bring that 76 and we put it up there. Can you read this number for me? 7605. How do you read that number?
7,605.
7. All right. I'm going to throw your name into the basket real fast so we can pull a name real quick.
We are just so delighted that we've had all of our callers representing schools all across Prince George's County.
All right, let's shake it up real fast. Shake it up real fast.
Shake it up, and we appreciate the callers. And this is
Ibram. All right. All right. Glenarden Woods.
Remember, you can join us here each Monday and Wednesday. Your elementary edition is from 4 to 5. And stay tuned, your secondary edition is coming up from 5 to 6. Remember, you can always
count on us. All right. Woo-hoo. Good job, Ms. Davis.
Welcome welcome to your mini lesson today. My name is Mrs. Jacks, and today we will discuss how to change mixed numbers into improper fractions, and the reverse of that, how to change improper fractions into mixed numbers or whole numbers. Let's go ahead and look at an example. In this example here, once again, it says changing mixed numbers to improper fractions. We have a mixed number here. A mixed number is when you have a whole number paired with a fraction. This one happens to be 3 1/8. We're going to go ahead and change that into an improper fraction. The first step is to multiply the whole number by the denominator. So 3 times 8 is 24. After you do that, well, let me go ahead and show you. 3 times 8 equals 24. You have the numerator here. We're going to go ahead and now add the numerator to our product. 24 plus 1 equals 25. This final answer becomes your new numerator, and the denominator stays the same. So 3 1/8 changed to an improper fraction happens to be 25 over 8. An improper fraction means that the number on top, which is the numerator, is greater than or larger than the number on the bottom, which is the denominator. We can also reverse this. We can change improper fractions back to mixed numbers, and I'm going to show you how to do that now with this second example. Changing improper fractions to mixed numbers or whole numbers. This first one here is an improper fraction. Once again, that means that the numerator is larger than the denominator. The first step is to divide the numerator by the denominator. Okay, so I'm going to set this up as 56 divided by 7. If you already know the answer, you can of course put the answer here, or you can set it up the long way using an algorithm. 7 goes into 56 8 whole times. 8 times 7 is 56. And then with the algorithm, you will go ahead and subtract, and your answer is 0 here, so you don't have anything left over. There's nothing else to continue dividing by. So your answer happens to be 8. So in this case, you can change an improper fraction to a whole number. Let's look over here. This one is a little different. This is 55 divided by 7. So it's one number less than 56. Let's see what happens when we do that. 55 divided by 7, we will do it the same way. 7 goes into 55. It doesn't go exactly 8 whole times. It's going to go in 6 times, and then we're going to have something left over. So let's go ahead and set up the algorithm. 55 divided by 7. Well, I'm sorry, I said 6 times. Excuse me. It goes in 7 whole times. So 7 into 55 is 7. 7 times 7 is 49. To complete the algorithm, you need to go ahead and subtract. 55 minus 49 gives you 6. So 6 is your remainder. Now, to set up our answer, the whole number here becomes our whole number for the mixed number, and then the remainder becomes the new numerator, and guess what? The denominator stays the same. So 55 sevenths, which is an improper fraction, now becomes 7 6/7 as a mixed number. Once again, this was a short mini lesson on changing improper fractions to mixed numbers and changing mixed numbers to improper fractions. Thank you for your time.
Minds can achieve anything. We make sure they get to college. Federal student aid provides more than $150 billion in grants, loans, and work-study funds to make college possible for anyone with the mind to get there. Because if given the chance, minds will do great things. Federal Student Aid, proud sponsor of the American Mind. Learn more about money for college at studentaid.gov.
how many ways are there to solve math?
Many! Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is
2 times length plus 2 times width.
Hey, welcome back. This is the
Welcome back.
second hour of Count on Us. This is a secondary edition. We ask the higher level questions because we have higher level people out there at middle school, high school level. So, my name is Ted Herman.
And I'm Miss McCants.
Miss McCants.
We would like to say what?
Happy New Year! I mean, this is not the way you dress regularly,
We have
is
the
it?
bell. Let's ring the bell.
Oh,
We
ring
got
the bell. Ring your bell.
Ta-ta. Happy New Year.
Man, you got like a
The maracas.
maraca bell. And make sure you call us at 301-772-0080 because we love to hear from your lovely voices and all your intelligent questions. You can also read us on World Wide Web.
Yes, at pgcps.org. And they would look for channel 96 and 38 as the link.
Oh, beautiful. And we have some challenges today, Miss McCants.
We do have a problem of the day.
All right. What's that all about?
So it says, how many more milligrams of calcium does 1 orange have than 1 banana?
There's some key words in that problem.
How many more milligrams? So we need to identify those words that are helping us with our operations.
Absolutely.
Okay. We have another challenge, don't we?
We have the challenge 24.
How does the 24 challenge work?
Well, every circle has 4 numbers in it. And these numbers here, like 14, 9, 3, and 2.
And how do you know that's a 9?
That's a 9 because it's colored in. People are calling in left and right.
I see.
It's unbelievable.
I'm going to go on to card B. Card B is 1, 7, 4, and 5.
And card C is 2, 7, 6, and 8.
And card D is 8, 8, 2, and 5.
And that's probably the hardest one because it has 3 dots. And the object is to take all 4 numbers. You have to use all 4 numbers, multiply, add, subtract, divide, any way you got to do it to make 24 out of all those 4 numbers happening there.
Okay. So that's our 24 challenge. We're going to leave the problem of the day up so that they can copy down the important information from the table. Leave that up there for a few minutes or a few more seconds. Because we have a couple of callers already lined up for us.
I'm tickled to death.
Okay, so let's get to it.
Well,
so who's going to be our first caller for
who's
today?
our first caller out there? Who could you be? Happy New Year to you. Who are you?
Hello?
Hello.
What's your name?
TT Lofadari.
TT. I love your name. Happy New Year, TT.
I need help with my multiplication.
Do you? Okay, so what school are you calling from, TT?
3-digit divide multiplication.
Hold up, TTT. TT, are you playing the piano while you're doing the question? What's that piano music on here?
Huh?
Do I hear piano music in the background?
What? I didn't hear you that clearly.
Maybe the piano's too loud. Are you all playing the piano over there? Piano.
Oh. Put the piano down.
Put the piano down. Who do you have? The Incredible Hulk in your house? Put the piano down.
Stop playing the piano.
Okay, right. Well,
Okay, TT, what school are you calling from?
191
Okay, she wants to get right to
times 5.
191 times 5.
Don't mess with TT.
So, TT, what should we start with? We have our 5. What number are we going to multiply to 5 first? TT?
Yes.
I said, what number are you going to start multiplying to 5 first? Which number?
5.
5 times 1. And how much is 5 times 1?
5.
5. Okay, and what's 5 times 9?
45.
45. So if I have 45, what am I supposed to do with the 4 if I bring the 5 down?
Put it on top.
Put it on top of what?
The 1.
The 1. Okay, so now I have 5 times 1. What's 5 times 1?
5.
5 plus 4 is?
9.
9. Can you read this number to me? Can you see it?
955.
955. 955. 191 times 5 gives us 955.
What are you going to do next?
Okay.
Okay.
Did you need any other help?
Hmm?
Did you need any other help today? Did you want to try one of the challenges?
Yes.
Okay, TT, your name has gone into the treasure chest for calling in to count on us. And which problem would you like to try today?
Huh?
Which challenge would you like to try today?
Multiplication.
No, the challenge for the day. I asked you if you would like to try one of the challenges.
Oh, yes.
Which challenge?
Multiplication.
Okay, TT, we put the 24 challenge up here for you so that you can take a look at the numbers and then decide which multiplication you would like, what numbers you would like to multiply.
That's a great idea.
To get a 24, because you want your ultimate number to be 24 at the end.
Okay.
Okay, so we put the numbers up here, you copy down, and then give us a call back.
Okay.
Okay?
Okay.
It was nice talking to you.
Okay.
Okay. Bye.
That was fun listening to you and TT getting that problem solved.
Yeah.
And you know what? I noticed your glasses are so becoming.
You like them on me?
They look very shady.
Do they bring out my eyes?
Well, your eyes are still in your head, thank goodness, but they bring out a lot of beautifulness in your style.
Beautifulness. Ooh, that's a word.
Let's go to the next phone call out there. And who might you be? Happy New Year.
Happy New Year. Who are we speaking with?
Hello? I hear somebody.
I hear someone too.
Hello?
Celafina?
Hello?
Celafina?
Can you hear me?
Geraldine? Who are you?
My name is Geraldine and I'm fine.
Hi,
That's
Geraldine.
great.
Nice to speak to you.
You're not playing the piano, are you?
No.
Thank goodness. Otherwise, you got to put the whole thing back down the floor.
I just want to say Happy New Year to Geraldine.
Happy New Year to you too.
Thank you very much. What can we do for you today?
I need help on multiplying fractions.
Sure, Mr. Herman would love to help you with that.
I live for this moment. I'm hoping you're going to multiply some fractions, Geraldine, with me at your side. What problem do you have?
The problem is 2/3 times 3/4.
You want me to write that down for you, Mr. Herman? Read it again to me, Geraldine.
It's 2/3.
2/3
Times
3/4 times
Yeah, nice handwriting.
2/3.
Wow, you got a multiple
So
problem here.
is it 3 factors? Or is it just 2/3 times 3/4? And that's it.
Is that the way it's supposed to look, Geraldine?
Huh?
Can you see this on your TV screen?
Yes.
Do I have it written correctly?
Yes.
Okay. Mr. Herman is ready.
My God, I can't wait for this problem to happen. Well, Geraldine, can I ask you a question? Do you ever do a thing called cross cancellation?
What?
Or cross simplifying.
Do Do you just want to multiply these numbers straight across and get an answer and we got to simplify it? Or do you want to cross out some numbers by cross-canceling?
Nah, I do not want to cross out by canceling. Yeah, I don't want to.
Oh, okay. Well, we wouldn't want to make you do something against your wishes. So if that's what you don't want to do, then we're not going to do it. Because we never force anybody on this show to do something they're not used to. So let's go ahead and do this, Geraldine. What's 2 times 3?
It's 6.
And that 6 is times 2 now. How much is that?
6 times 2 equals 12.
Excellent
so
job.
The numerator would be 12.
Oh my goodness.
And I love your vocabulary.
I like that numerator word. And now we have 3 times 4, Geraldine. What's
3
that?
times 4 is 12.
And then times 3 more.
3 is 36.
Excellent. Why is this answer not finished?
Because it is not simplified.
It's not simplified. Exactly right. Do we know a number? I thought my head came off. I swear. I thought I lost my head. But Geraldine, you're doing great. Do you know a number that can fit in the 12 and 36? Something that we can divide 12 and 36 by?
Evenly, so it'll go in evenly.
12 can go into 36.
Oh my gosh. You know your stuff, Geraldine. So we're going to divide 12 by itself, and we're also going to divide 36 by the same 12, because 12 divided by itself is really 1 whole. So you can always divide anything by 1.
Wait.
So what's that make? 12 divided by 12, Geraldine?
12 divided by 12 is 1.
Good.
And 36 divided by 12 is 3.
I love your style. So what's your final answer for this problem?
1/3.
You are amazingly great. Your skills, I love it. Can we get your name into the treasure chest one time? And do you want to try the problem of the day problem, or do you want to try the challenge 24?
I would like to try the challenge 24.
Oh my goodness. I can tell you have a lot of confidence in yourself, and that's what it takes for math. A lot of belief in yourself. Okay. Did you already have a number picked out, a letter, A, B, C, or D?
I would like to choose
Thank you so much.
A.
A.
A. So you're going to go with 14, 9, 3, and 2. Did you already work these out? Or
No.
would you like to call us back?
Yes.
Okay, great.
Oh,
Geraldine,
okay.
we look forward to speaking to you.
14, 9, 3, and 2. I hope
Write
she
those
calls
down. You
back.
can do multiplication, division, addition, or subtraction, okay?
Excellent job there, Geraldine. It's a pleasure talking to you, and count on us.
Okay. So who do we have next?
I don't know. Who could it be?
Well, I'm going to use my magic glasses. Let me look out there in TV world. Celafina? Hello?
Hello?
Okay, it doesn't sound like Celafina. Celafina, I mean...
Could be Alzaro.
Who is it, Alzaro? You got your magic hat on.
Hello?
Hello, what's your name and what school are you calling from?
Hello. My name's Alvaro Cerrone.
Okay, and what school are you calling from?
In Woods Elementary.
Glenarden Woods?
Yes.
Okay, welcome. Is this your first time calling us?
Yes.
Well, welcome to Count on Us. I'm Miss McCants, and this is Mr. Herman. What is your math question for today?
Can I ask Alzaro one question? Alzaro, are you listening?
Can you repeat that?
Yeah, I just want to ask you one quick question, Alzaro, okay? Everybody's calling in from Glenarden Woods today. Is there a contest going on or a special giveaway prize at school? Or what's going on?
Alzaro, can you turn the TV all the way down and just talk to us through the telephone? I hear Mr. Herman, the feedback. Can you turn the TV all the way down?
Yes.
Okay, thank you. Mr. Herman wants to know, is there a contest or something going on at your school?
All right, that's okay.
Okay.
You can get back to us some other time about that, but I'll let you talk to your host.
Alzaro, what's your question?
412.
412
Multiplied 5.
multiplied to 5. You said multiplied by 5?
Yes.
Okay. So what's the first thing? Did I write this correctly? Can you see this on your TV? Okay, what's the first thing we need to do? I know that I'm going to multiply by 5, so what do I need to multiply first?
2.
2. So what's 5 times 2?
10.
10. Okay, so I have, I wrote down my 0. What do I do with the 1?
You put it on top of the number 1.
Okay, so I'm going to put it here. Now what do I do?
Now you multiply 5 times 1.
And what's that?
5.
And then what do I do with this extra 1 that I have here?
6.
I add it to the 5 and I get 6.
I mean, you add 1.
To 5 and I got 6, right?
Yes.
Okay, so now what do I do? 5 times what?
4.
5 times 4, and how much is that?
20.
20. Have a large number, so I'm going to rewrite this so it'll all fit. So it's, can you read that number to me? Would it help if I put a comma here?
Yes.
So can you read it now?
Now, can you repeat that?
What is this number that we came up with when we multiply 412 times 5? It's 2 what?
2060.
2060. 2060 is our final answer. Alzara, you did an excellent job helping me with this problem today.
Can Alzara say that answer one more time without using the word and?
Okay, so try it one more time. Do not use the word and.
2060.
Excellent job. Excellent job. Mr. Herman is ringing that bell for you, and he's also put your name in the treasure chest, so you need to stay tuned to the end of the show to make sure that you possibly could be the winner, correct?
Did he want to try a challenge?
I was going to ask him, did you want to try one of the challenges? Either the 24 challenge or the problem of the day? Alzara. It's no pressure. You don't have to if you don't want to.
I do want to do the 24 challenge.
Okay, great. I have the 24 challenge cards up here for you. Take a look at them and decide which card you would like to do. Did you already write down the numbers?
Not yet.
Not yet. So go ahead and take a look and write down the numbers you would like to work on.
The card I would like to use is...
This is A, B, C, and D.
I would like to use A.
Card A. Card A is 9, 3, 2, and 14.
Okay.
Okay. So you're going to do it now or you're going to call us back?
Call you back.
Okay. We will be sitting right here waiting for you to call us back. Okay. So thank you, Alzara, for calling.
You're welcome.
I'm going to hold my breath till he comes back.
Okay, don't hold your breath now. You're going to be
Who's our next caller out there?
We need you to stay focused.
Stay focused. Thank you. Who is that on the air? Hello? Hello?
Geraldine? Geraldine, are you there? Okay, well maybe Geraldine's not there.
Where is she?
I don't know. Oh well. So let's talk about this problem of the day. Let's get back to that one. Yeah,
let's get some more focus on that.
It says, how many more milligrams of calcium does one orange have than one banana? What do you think is very important?
Well, I think it's very important that we have words because the words are important to a word problem.
Okay, that is correct. So now let's move past those words and look at this table. What do you think is important on this table?
Oh, you know what I think? I think there's two fruits that are really important to the answer to this problem.
That's right.
And there might be 2 other fruits that have nothing to do with the answer.
And that's exactly my point.
What's your point?
Okay, I think we have a caller. Caller, are you there? Hello? Okay, so we're going to go back to this problem of the day.
Where's Rose? Is Rose out there? Hello? Rose?
Rose, are you there? Okay, so back to the problem of the day.
Oh, yes.
So you said there's 2 pieces of fruit that we really need and 2 pieces of fruit that we don't even need. They're just stuck on there just to trick us.
Right, because we read the problem carefully. I only see but 2 fruit in the problem.
And those other 2 fruit are trying to distract us, maybe.
Oh, my gosh, I like that word.
Distractors.
Distractors. That must be a math word.
It is.
Is it? I like that. Plus, I see a word like more, and a lot of times you see more in a problem, you'll see the word than, and that means something. It's either addition or subtraction.
Well, how about how many more than?
How many more than? That makes it into a question.
Yeah.
That's why there's a question mark after banana.
You're so smart.
Well, I worked at it, but I only get my knowledge from your brilliance. So, how many more milligrams of calcium does 1 orange have than 1 banana?
So what could we eliminate?
I like that. I do a thing in my class called I'm sure you do too, POE. Process, you want to finish that off? Process of
elimination.
You got it. So I'm going to cross out the apple.
No apple.
And I'm going to cross out the peach.
Okay, no peach. But I like peaches. Why do we have to cross that out?
Well, you can do peaches on your own time, but as far as this problem, it's not relevant. It's not.
You're exactly right, because I only see orange and banana.
Thank you. So those are the 2 fruit we're going to compare.
And it says how many more than.
So that's either addition, subtraction, multiplication, division.
That's all 4 of the operations. Okay. So you want to take one more call before we go to break? I see that someone has called in.
I think, is that Celafina coming back on our...
I think Celafina's back.
Celafina's
Hello,
back.
Celafina.
We gotta talk to Celafina.
Celafina, are you there?
Celafina, come on, girl.
Hi.
Hey, Mr. Herman has been dying to talk to you. How are you been?
Good.
That's great. What's your question?
Celafina wasn't the one on the piano, was she?
No.
Oh, good.
That was
7 minus 5 and 1/4.
7
minus 5 and 1/4. Well, you know what, Celafina? I bet you know a lot of stuff, but there's something bad about this problem. That 7's a whole number, right? Minusing 5 whole number, but a fraction 1/4. That's a mixed fraction. Where is the fraction up here? Celafina.
You have to rename it.
Yeah, I was just about to suggest
What'd she say?
that. You have to rename it. Which one? Should we
Oh,
rename
my
the
goodness.
7 or the 5 and 1/4?
The 7.
She's so smart.
She's great. I'm going to use black
Sure.
ink if you don't mind. I'm going to just borrow. How much should I borrow from that 7? Just 1 whole, right? What's that going to leave us with? How many holes are we going to have left out of that 7?
6.
Yes. But we're going to bring over 1 whole. But now we're working with fourths.
So what do you think our new fraction should look like? How should we break up our 1 whole? Mr. Herman is giving you a hint.
1/4.
Not 1/4, but if we have a whole,
I'm going to color in all of them.
4/4.
Yeah, so 1 whole is really the same thing as 4/4. So I'm going to remove that 1 because 1 whole is the exact same equivalent to 4/4. Now, can we subtract, Celafina?
We have 6 and 4/4 minus 5 and 1/4. How much does that equal?
Looks doable to me. 4/4 minus 1/4. Come on, Celafina.
3/4.
Okay.
Oh, go right. You're doing great. I like your handwriting.
Thank you.
And what about 6 holes minus 5 holes?
1 whole.
Beautiful. How do you say the whole? How do you say this mixed fraction?
How do you say this mixed number?
1 3/4.
Booyah! Oh yeah! Oh yeah!
Excellent
Celafina.
job. Your name is going into the treasure chest. You're going to get it?
Sure.
Celafina, thank you so much for giving us a call today.
Does she want to try a challenge?
Did you want to try a challenge? I can put the 24 challenge card up or the problem of the day.
Yes, I want to do the problem of the day.
Oh, she was paying
wonderful.
attention.
You were paying attention.
I bet
so
she's
we're gonna
watching
put
the
that
show.
up there right before we go to
goodness.
break. So this is the last thing
love
you're
it.
going to see before
I
we
love
go
it.
to break.
Mm-hmm.
How many more milligrams of calcium does 1 orange have than 1 banana? So you work on that while we're going to break. And on the other side of the break, you can call us back.
Mm-hmm. Get right back to us, Celafina.
I have the answer.
Oh my goodness, go for it, girl.
45 milligrams.
How'd you get that?
That is a smarty pants.
How'd you get 45?
I subtract 52 milligrams from the orange. I subtracted 7 from 52.
And that gives you 45 watts?
What is the units that they're using?
Huh?
The units.
How do we label it? 45 watts?
They want to know how many
45
more.
milligrams.
Excellent job.
Oh my
That is
gosh.
a
She's in there.
superstar.
She's in there. We're putting her in
Putting
the
your
box.
name in the box.
In the box, girl. 2 times right there. Let's go to a short break.
Okay, we're going to go to a short break and we'll see you right back.
Oh, good.
Hi, I'm Cameron from Samuel Ogle Middle School, and today's email question is from Ted at Rockledge Elementary. Ted wants to know the area and perimeter of a rectangle that measures 3 inches by 6 inches. Well, let's start with the perimeter. The perimeter is round. So we add all the sides. Okay, so we know that if 3 inches is on this side, then 3 inches is on this side. And if 6 inches is on this side, 6 inches is on this side, because the opposite sides are equal. Now we add 6 plus 6. 6 plus 6 equals 12 inches. And 3 plus 3 equals 6 inches. Now 12 plus 6 equals 18 inches, which is the perimeter. Now we do the area. The area is the inside. So we can either count the squares or we can do length times width. And the length would be 6 inches. And the width would be 3 inches. So let's do both. First, we'll count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now we know that we have 18 inches squared since we used the squares. And the same thing goes for length times width. So now we do 6 times 3. 6 times 3 equals 18 inches squared. And this is the area. Well, Ted, I hope that was helpful to you. So, that's Cameron, and see you next time. Wait a minute. That's wrong. All people are people.
Take the time to get to know people, and you'll see that all of these labels are false. Don't let prejudice shape your view. Stereotyping is wrong, and it hurts all of us.
Stop stereotyping.
A message from your American Muslim neighbors.
When I was a kid, I dreamed of being a stuntman.
I went from dream to dream pretty quickly.
I wanted to be a cowboy.
Tom Cruise and Top Gun.
I dreamt of being a nun.
Actually, before that, it was Popeye.
Malaria kills more than 2,000 children a day.
Text NET, N-E-T, to 85944 to make a $10 donation to Malaria No More.
Oh, messaging and data rates may apply.
Let's make malaria no more.
Welcome back to Count on Us. I'm Miss McCants, and this is my lovely co-host, Mr. Herman.
I must be wearing the hat the wrong way.
Wearing it with some swag.
Make sure you call us at 301-772-0080, and you'll get all the answers you ever had for all the problems you might have had in math.
Okay.
And you know what? We had a lot of great callers so far.
We did the first half.
Let's hope it keeps it going
We have a new problem of the day up because the first problem of the day was solved right before we went on the break.
Yeah, that was amazing.
So let me straighten this up so everybody can see.
I wish you would straighten up a little.
It says write a number expression, give its value. Antonio had $134 in his savings account. He put $67 more. I'm sorry, he put in $67 more. How much was in Antonio's account then?
So our good readers and listeners out there should be able to figure this one out.
Because they have to create an expression. Notice the word expression.
That sounds like it's algebra to me.
A little bit.
A little bit.
And then we're going to go to our 24 challenge.
I love this part.
So the 24 challenge is we're going to take a combination of 4 numbers, addition, subtraction, multiplication, and division. Use any combination they want with those 4 numbers that are on the card and come up with the 24.
Fantastic.
Okay.
Fantastic.
All right.
Well, we got those callers all lined up out there. They're ready to come on the show with us. We got everybody. We got Don Trez. We got Rose back. We missed Rose the first time.
Geraldine.
And Geraldine's coming back again to be part of the show.
All
so let's go to our first caller who I have no idea.
I have no idea. Ready?
Don Trez?
Don Trez, is that you?
Yes.
Hi, how are you? Welcome to Count on Us. What school are you calling from?
Huh?
Welcome to Count on Us. What school are you calling from?
Well, hold up. This is a neighbor, and I was just coming over to call, and I went for a problem.
Yes. What school are you calling from?
Oh, Thomas Johnson Middle School.
Okay, nice to have you. Is this your first time calling us?
Yes.
Okay, well, welcome to Count on Us. What is the problem that you called in with?
This could be a problem, though. Are you supposed to be in the house right there? Does anybody know you're in the house?
Yes.
Okay, great, Don Charles. What is that question that you have for us?
I'm turning a fraction into a decimal.
Okay, a fraction to a decimal.
This is a drop-in call from anybody on the street.
What
That's
is that
wonderful.
fraction?
3/4.
3/4.
3/4.
3/4. 3/4. Okay, so there are a couple of different ways we could do this.
What are they trying to do again? I'm sorry.
He's trying to change this fraction
Into a what?
to a decimal.
Oh, that's nice.
Okay, change the fraction to a decimal. And what I've learned is we can turn 4 and 3 like this and put it in the house.
Put it in the house? Just like Don Trez came into the house?
Just like Don Trez into the house.
Okay, so now you're dividing, looks like.
But Don Trez, because I have a 4 as my divisor and 3 as my dividend, do I have enough to divide into?
No.
No, so that means I have to annex the 3.
Annex?
I have to annex the 3, which means I have to put a decimal behind the 3 and place a 0 behind the decimal.
Man, that's cool.
And I'm going to go ahead and put a decimal in my quotient. And you said I don't have enough to divide 4 into 3, so I'm going to put a 0 here. Okay? So, do I have enough now if I have 4 goes into 30?
Yes.
How many times?
7.
7 times. Okay, so 4 times 7 is how much?
28.
It's 28. Excellent job. So, can I take away 28 from 30?
Yes.
What's left over?
Huh?
30 minus 28, how much is left over?
2.
2. Okay, and now can 4 go into 2?
No.
No, so I need to add another 0 up here in my dividend. Bring that down. So now I have 20. 4 divides into 20 how many times?
5.
5 times. And 5 times 4 is how much?
20.
20. 20 take away 20 is how much?
0.
0. Do we have anything else that we need to divide 4 into?
No.
No. So what is our final answer? What is our quotient?
75.
75 what? Because we have it behind the decimal. So it's 75 what?
Percent.
Not percent, because you asked me for decimal, remember? So how can we read this as a decimal? What place is this in? We have a decimal, which means right behind the decimal is what place?
10.
Tenths, with a TH on the end, right?
Yes.
So what would be right after tenths?
Dollars.
Not dollars.
100.
Hundreds. Excellent job. So now we have tenths and hundreds. So read it as 75. And what's that decimal place?
100.
75 hundredths. Excellent job. So 3/4, go back to the original question, 3/4 change into a decimal will be 75 hundredths.
Nicely done there, Ms. McCanson, Don Trez. I would say, I heard Don Trez say something about 75%, so that would be true as well. If you move the decimal, how many places over? 1, 2.
2 places to the right, but then the mathematical value behind that would be him taking the 75 hundredths and multiplying that by 100.
Oh,
he's just not moving it 2 places to the
Right,
right. He has to know why he's moving it 2 places
Because
to the
percent is based on 100.
That's right. We're basing it on per 100.
Per 100. Per.
Okay. So that would be 75%. And you are correct with that.
Wow.
Okay.
So Don Trez, get your name right into our treasure chest
And
for the
Don Trez,
drawing.
thank you so much for calling in. Did you want to look at the challenge questions before we move on?
Could you repeat that?
Did you want to look at the challenge questions before we moved on?
Yes.
Okay. Which one would you like to look at? The problem of the day or the 24 challenge?
Problem of the day.
Yes, sir.
We have to move on before Don Trez moves on back to his house.
Okay, so here is the problem of the day. Write a number expression. Give its value. Antonio had $134 in his savings account. He put in $67 more. How much was in Antonio's account then?
201.
201. What do you think, Mr.
Pretty
Herman?
darn good. I want to know how Don Trez knew that.
Okay, so Don Trez, what can you walk us through your thinking?
I added. Well, before it said that Antonia had $134 in his account. So
So does that mean he started with $134?
Yes.
Okay.
And then I saw the word he put in, so that told me he added money to 134. So when I saw that, I knew I had to add, so I added 4 plus 7, and I got 11.
11.
And then I did 6 plus 3, and I got 9.
Plus 1.
And then, but there was a 1 at the top,
That's
so
right.
I added 10. So I added 9 plus 1, and I got 10.
That's right.
So I added the 1 onto the 1. Then my last number to add was 1, but there was a 1 on top of that 1, so I did 1 plus 1. And I got 2, and I put it at the bottom.
So your answer, your final answer, or your final sum was $201.
Yes.
Excellent job, Dontrez. And I'm
His name's
so happy
going
that
right
you were
in
able
again.
to explain that to me because you solved that so fast. I was like, man, he's a
He must have
superstar.
done it mentally or something. That was very good.
You are an excellent student,
Nice job,
Dontrez.
Dontrez.
Thank you so much
Very
for calling.
impressive.
Mr. Herman, put your name in the treasure chest
Happy
twice.
New
One for
Year.
calling in and another for solving the problem of the day.
Happy New Year. That's
Happy New
great.
Year to you, too.
Oh,
Thank you so much.
Dontrez.
You have a wonderful
A
day,
pleasure
okay?
talking to you while you're out there. Okay, next caller is that Geraldine?
Hello? Can you hear me?
Yes, we can hear you.
Can you hear me?
Okay. Okay, sorry that you guys called my name. It's just that the phone kept on cutting off.
Oh, okay. I'm glad that you were able to call us back, Geraldine. How are you doing? You ready to give us a 24 challenge?
Yes, and I actually found 2 ways.
Really? Well, we only need one way, so let's hear it.
Okay. 14.
14. So you're doing card A, right? 14,
Yes.
9, 3, and 2.
Mm-hmm.
Okay, you said 14.
Okay. 14 minus 2
14 minus 2
is 12.
is 12.
And 12 plus 3 is 15.
12 plus 3 is 15. Excellent job.
And 15 plus 9 is 24.
15 plus 9 is 24.
Happy
Excellent
New Year.
job.
Happy New Year.
Let me shake my little...
wow. Whoa. That is exciting news.
Excellent job, Geraldine. Thank you so much for calling back with that solution to the problem. Mr. Herman
Hold
is putting
on.
your name
Hold on. This just came in. A
Uh-oh.
bulletin. Geraldine got
Late-breaking
that word problem right. I'm so proud of her. Nice job.
Okay, Geraldine, your name is in the treasure chest. Thank you so much for calling back, and you need to stick around to make sure, well, maybe that you are the winner when we pull the names out of that treasure
a lot
chest.
of names.
Yeah.
Way
okay.
to go, Geraldine. That's called
Have a good night.
perseverance. You ever heard of perseverance?
Mm-hmm.
Never gave up. Kept trying to get it right. Next
right,
caller
who's
out
next?
there. Who could you? Is that Rose?
Yeah.
We
Hey,
missed you
Rose.
last time, Rose. Where'd you go?
Yeah, the phone kind of, didn't have signal well.
Okay, so it went out on us. Well, I'm glad that you're back, Rose. What's your question? Mr. Herman is dying to help you.
Stop saying dying. I have a bad heart to begin with.
8.
What?
8.
My
What?
question is 8 and 2800.
8 and 2800ths. I love your vocabulary.
I'm glad. What school is that? Catherine something.
Rose, can you turn your TV all the way down and just talk to us through the telephone?
Uh-huh. So my question is 8 and 2800 times 5.
Times 5. There you go, Mr. Herman.
Oh, thank
It's
you
all
so
yours.
much, Mr. Cantz.
Mhm.
All right, Rose, start us off. How do you get started with this problem?
We're going to have to multiply.
Try this. 5 times what?
So we're going to have to multiply.
Mm-hmm.
We're going to have to multiply 8 times 5.
And what do you get on that? What is 5 times 8, Rose?
40.
And what goes down?
The 0 goes down and we carry the 4.
Beautiful job. Now, 5 times 2.
It's 10.
Mm-hmm.
And what about the 4 up top?
It's 14.
Beautiful job. And carry the what?
1.
And 5 times 8 again.
40.
Plus the 1.
41.
Excellent job. Now, how do you know where to place a decimal point?
We put it between the 41 and the 40
How do you know that?
because I bring down the decimal.
No, you don't bring down a decimal, sweetheart. You have to count how many places over from the right side. 1, 2. See how I got to the decimal point? 1 move, 2 moves. And you come down here and you count the same 1, 2, and decimal point goes there.
But the decimal place is in the correct place. You did say it goes in the right spot, but you need to make sure why you're moving it that way.
Right.
Okay.
Can you pronounce that number, that decimal number you got for the answer?
41 and 40 hundredths.
I love it. I love it.
Could we also say that this is 41 and 4/10?
Yeah.
Yes, we can.
Cover the 0.
That's right. If we covered up that 0.
Oh,
Okay.
interesting. So Rose gets her name right.
Rose, your name is going right in the treasure chest, okay?
You want to try a challenge today, Rose?
I want today's challenge.
Okay, which challenge would you like to try?
A multiplying one.
You can write down the numbers and to see if you can multiply any of these to come up with 24.
8 times 3.
No, we don't have 8 times 3. You got to look at these cards and decide which one you would like to try to use.
To get 20?
24. We're trying to get to 24.
Maybe you can talk to your brother Isaac.
24.
Okay, so we're going to move on to the next caller, and you can give us a call back, Rose, okay?
Okay.
All right.
Nice job. Next caller, I think, is
David?
David?
Hello?
Hi, how are you?
Good.
Is this David?
Yes.
Welcome to Count on Us. What school are you calling from?
Kenmore Middle School.
Kenmore Middle School. Welcome to Count on Us. What is your question?
Hello?
Hello, what is your question, David?
I mean, that was the question. Hello?
My problem is finding the mean of 6 numbers.
Okay, so what are the 6 numbers?
What do you mean by
80,
mean?
82,
What's mean?
89.
Fine. The average.
Okay,
90.
So you said 80, 89, 90,
82,
82,
81,
81,
and 78.
And 78. And you have to find the mean. What is mean? What is mean? What is the definition of mean?
Well, you're basically trying to find the average.
That's right. We're going to try to find the average, okay? So to find the average, we need to do 2 operations. What's the first operation?
Adding.
We need to add. What's the second thing we need to do?
Divide.
Divide. Okay, we're going to add and divide. Okay? So Mr. Herman is going to help us out and put the numbers in the calculator for us. So we know that we have 80, 89, 90, 82, 81, and 78. And all of those added together gives us 500, right?
Yeah.
Okay, so our total is 500. After we add all of these numbers together, 500. Now, how many numbers do we have all together? 1, 2, 3. We have 6, so that means we're going to divide 500 by 6. Okay. Mr. Herman? 500 divided by...
Oh. Well, does he
6
get decimal answers when he does his problems, do you know?
It's 6 and 50.
Okay, fine.
6.
You take off the last 0. Since 6 can't go into 5, you go to the second number, and that's 50.
Okay, so you're saying go here to 50 because 6 won't go into 5. 6
Right.
goes into 50 how many times then?
8.
8. And then that leaves me with 48, right?
Yeah.
And then I'm going to subtract 50, take away 48 is how much?
2.
2.
And then bring down the 0.
And bring down the 0. So 6.
And then 6 goes into 23 times.
And 6 times 3 is how much?
18.
18. And I'm subtracting that, and I come up with what?
2.
2. So does it go?
What I do is add 2 decimals to the 500.
Okay, so you added 2 decimal places to the 500.
Yeah, 2 zeros.
Uh-huh. So you annexed the 0 and added another 0 and came up with 20. But what did you notice when you did that, David?
It's a repeating decimal.
It's a repeating decimal, so that means our final answer is going to be 83 and 3/10 with the bar over it.
Beautiful. Beautiful.
83 and 3/10 with the bar over the last 3. Okay?
Yeah.
David, you did an excellent job on this question. What grade are you in?
6th grade.
You're in the 6th grade. You are a smart young man. Thank you so much for calling in, and I hope that we helped you.
Do we have time for one more caller, you think?
I think we might have time for one more caller.
Who's that out there? How do you say your name?
Isaac, is that you?
I think it's A-R-A-B-A.
Or is that Araba?
Hello?
Hi, what's your name?
Araba.
Okay, Araba, I'm pretty good with that.
That was very nicely smooth.
What's your question?
My question is 7,208 times 5.
7,208 times 5. Go, Mr. Herman.
I'm going fast.
Go fast.
We got to roll. We got to roll this problem up. All right, Araba, go. 5 times 8.
40.
Excellent. Carry the 4. What's 5 times 0?
0.
And the 4?
4.
Right. And then 5 times 2.
10.
Carry the 1. And 5 times 7.
35.
And one more.
36.
And then we go 1, 2, 3, cha-cha-cha. Can you say that answer?
36,040.
Outstanding.
36,040.
Way to go, Araba.
And Araba, your name is going into the treasure chest.
Thanks for calling in from Calverton Elementary School. I think it's about that time of the show. We got to pick a winner.
We need to pick a winner.
But we have so many winners. We must have like
Shake,
11,
shake,
12,
shake,
13
shake, shake.
names in here. All these great callers. All these smart students in Prince George's County schools. And you're so wonderful.
I'm
Those
gonna
cool
check. Wait.
glasses you got there.
Okay,
what did
whose
you
name
pick?
is that? Cellophina.
Cellophina.
You are the winner.
Happy New Year to everybody.
Happy New Year, everyone. And thank
stay
you for
tuned.
calling Count on Us.
Call back on Wednesday. We'll be back on the elementary edition, 4 o'clock. Be safe and stay warm, and you can always count
on us.